Hi, Zulichle and Mpo. See, I remembered. Mpo and Karabo. I've remembered. And Asipe is here. Such a happy picture you've got, Zulichle.
We all love it. It's our favorite.
Yeah. Okay, so there is a question up on the board. I thought tonight we'd tackle some analytical geometry. So have a look so long. It's from that same paper we've been working on and that Lee also did with you on Monday. So she told me she did some trig and some circle geometry and ratio and proportion. So I thought we'd tackle these analytical geometry questions this evening. So have a look so long, have a read through. And I think as you just read through, and then I want you to circle the ones that you think you can definitely do and that you think are the routine questions. In other words, routine questions are the very straightforward questions that's not too difficult, that you know from studying. And then mark the ones that you think are difficult and that you would struggle with. So do that now while we wait for everyone to arrive. Asipe disappeared. I hope he's coming back. So Likhle, have you finished your exam? Have you written both your papers?
Yes, I have, ma'am. I'm done with my trial now.
Okay, great. But you're still here with us, or are you just carrying on grinding it out?
Nothing much I can do really, because I don't have to study for any paper, so yeah.
Oh, wise woman, just using your time for maths. That's great. Michaela, welcome. Timothy is back today as well.
Yes,
welcome.
It's nice to see you, Timothy. We missed you on Monday. He wasn't here.
Okay. I also wasn't here on Monday, Timothy. So we're both back. That's
Sorry,
great.
We missed you, Marlies.
Oh, but Lee was here.
Yes, that was great as well. Yeah, we did a couple of paper 2 questions as well, so that was really good. Hi, Jaden.
Is Jaden here as well? Hi, Jaden. Timothy, have you written your paper 1 and paper 2 yet?
Yes, I have written my paper 1 and paper 2, but things aren't looking very good.
Okay, well, you still have time, so you've come to the right place. I'm very proud of you guys for sticking it out and for persevering, even though you've written your exams. Oh, Benedict, you've written as well. And paper 2 is something else. Your paper 2 is always seems to be the one that just gets everyone. I wonder why. Maybe because the content is a lot.
I don't know about you, Marlies, but when I was in matric, they used to make our trial exams very difficult so that, they would make us study a lot harder for our final exams. So, don't fret too much. It'll be okay, Benedict. I think it's worth learning from your mistakes, because I'm pretty sure if you can get through trials, your final exam is going to be a breeze. Don't worry too much.
Yeah. My trial exam was so long ago, I can't remember it anymore. It's a very distant memory. So, yeah, guys, take encouragement from that as well. Like, a few years from now, you're just not going to remember it anymore. Will just be a little blip on the radar.
Exactly.
Hey, Kaka.
Yes, I don't remember a single thing I wrote or whether I did great. I don't even remember my matric marks, to be completely honest. So, yeah.
I mean, mine was so long ago, it was like 5 different curriculums ago, I think.
Oh, goodness.
The curriculum has changed like 5 times since I wrote my matric.
Wow. Yeah. We are old. We're very old.
Okay, I'm going to stop now before I give away too much of my age. You guys still have lots of time ahead of you.
Yes.
Right. Let's go. Let's see this question. So it's question 3. Question 1 and 2 would have been, who knows? Question 1 and 2, that's your stats, right? So after you cruise through the stats, you get to question 3, because you got to cruise through the stats. I'm actually leaving question 1 and 2 till last, because that's normally about 20 marks. And if you're getting, like, say, 40% or 50%, and you want to go up 10%, you really need to nail the stats. And that's question 1 and 2. So I'm going to leave that till the end. So I'm doing we're doing the order of the questions all over the show. But today is question 3. And this is normally where the analytical geometry starts. Okay. So like I said, and this is a technique that you can use, we see here that this is 18 marks. So you've got about 18 minutes to complete this question. Work on about a mark a minute. So spend a minute or 2 just reading through it and seeing which ones are easy. So you go, the midpoint of EC, yep, that should be fairly routine. The gradient of DC, yeah, I've got the 2 points. I've got the formula on my formula sheet. Yeah, that I can do. Then the equation of AB in the form y equals mx plus c. So AB, okay, might require some thinking. Not so sure about AB. And let's see the mark allocation is 3 marks. So maybe a little bit more complex, maybe a little bit on the complex side, a little bit harder. And then the size of theta. Now, theta is over there, probably also a little bit complex. And in 3.2, we have to prove that AB is perpendicular to BC. AB is perpendicular to BC. What do I know about lines that are perpendicular? The gradients multiplied together must equal -1. So, yeah, fairly doable. Let's make that a routine question as well. And then we have to do, what's next? Just move the screen. The points E, B, and C lie on the circumference of the circle. Determine the center of the circle. So that's 1 mark, so it's got to be easy. It's got to be routine. So I think we're going to mark that as routine as well. And then the equation of the circle in the form x minus a plus y minus b is r squared. The equation of the circle is definitely a routine question. You got to know how to do that. So everything that I've marked with an R that is routine are things that you should get mostly right. Okay. So now you can look for yourself which ones you marked as feeling confident about, which ones you think are going to be a little bit more difficult. And now we're going to start. So the midpoint of EC, 3.1. So there's EC. I've got the coordinates of E. I've got the coordinates of C. I can just plug that straight into my midpoint formula, which you don't have to remember because it is on your formula sheet. So I'm going to write it down, but it is on the formula sheet. And to save time, you can just plug straight in. You don't have to rewrite the formula, okay? Very important. I see a lot of people waste time rewriting formulas. Don't have to rewrite the formula, but you have to do the substitution into the formula correctly. So that's y2 plus y1 over 2. And my x coordinate, I can take minus 2 plus 2 over 2. And y coordinate is 0 minus 3 over 2. And that is going to give me 0 and minus 3 over 2. That is the midpoint of EC. Okay. Now we have to do, so that's 2 marks, done, happy, moving on. Okay, I just need to sort out the space here on my, create a bit more space. Where should I do it? I'm going to do it up here. So 3.1.2 is the gradient of DC. Gradient, also on your formula sheet, you don't have to rewrite the formula, but the formula for the gradient is y2 minus y1 over x2 minus x1. And you can just go straight ahead and plug the values in. So that is minus 3 minus minus 5 and 2 minus minus 2. Okay, so I hope you're working with me and checking that you are getting these answers as well. So minus 3 plus 5 is 2 over 4, which is a half. Okay, and you can check if that makes sense. So I get a half. And yes, the line slopes in the positive direction. So yeah, I think that's right, a half. Okay. So far, yeah, 2 marks for each of those. Should have taken you about 4 minutes to do if you're in the exam. But how do you speed things up? By not rewriting the formula, just substituting in, and of course using your calculator very fast, and also, but also even better if you can do it in your head. But don't hesitate to use your calculator if you're scared you're going to make a mistake. Okay, now we have to do the equation of AB in the form y equals mx plus c. That's 3.1.3. Equation of AB in the form y equals mx plus c. Okay, I marked it complex, but I'm actually looking at it now and thinking it's not so bad, because I just worked out the gradient of DC. The gradient of DC we calculated was a half. And here it shows me that this line, these lines are parallel. It actually also mentions that this A, B, C, and D are vertices of a trapezium. Okay, so those sides have to be parallel if you have, if that's a trapezium. So that means the gradient of AB must also equal a half, because the gradients of parallel lines are equal. Okay, so now we're already halfway there, because if we have to do y equals mx plus c, then the gradient is a half plus c, and now we just need to sub a point to find what c is. So we sub a point on the line AB, and we only have one point given, and that's E, minus 2 and 0. So 0 of minus 2 plus C, and just going to make a line here, I should have really given myself more space here, but anyway. So then that gives me -1 plus C. So C is going to be +1. So therefore, okay, this is important because you can do all that lovely work, but if you don't answer the question, don't get the mark. So end off with what is being asked. It's asking for y equals mx plus c. So then your answer at the end must be y equals mx plus c. So you worked out a half x plus 1. That's the equation of the line. So I'm actually going to change that to make it a routine question, because you have to know, it's like a no-brainer, that parallel lines, the gradients are equal. And you have to know how to find the equation of a straight line. Find the gradient, sub a point, solve for C. That's basically always how you do it. Okay. Right, so have a look at that so long. I'm just going to move things around on my board a little bit so we can have more space. Now we have to calculate theta. Okay. Now you will get a question on angle of inclination. I'm going to leave this question as complex because it isn't straightforward. But you will get a question in analytical geometry on angle of inclination. And for that, you immediately have to think tan of an angle is equal to the gradient. So if you have the gradient on your calculator, you go shift tan, that gives you the angle. If you have the angle, then you tan that angle with your calculator, and that gives you M. That gives you the gradient. So that's what this question is basically about. But you have to go a step further here and think about how you will actually find that angle theta. Because the angle of inclination is always, I'm just going to highlight our theta that we are looking for over there. The angle of inclination is always the line, the angle that the line makes with the positive x-axis. So this angle here that's marked alpha, that one, we've just calculated the gradient of AB, or we just figured it out because it is parallel to DC. So that angle we can most certainly get because that is the angle the line makes. We can't go straight there to the orange angle, theta, because that is not an angle with the x-axis. Your angle must always be with the x-axis. If it's not, you have to use some geometry to figure it out. And in this case, we are going to use geometry plus angle of inclination to figure out what this angle theta is. Okay. Right, so let's start with alpha. Tan of alpha is equal to the gradient. That's a half. So alpha is going to, so you just take your calculator and you say shift tan a half. And that gives you 26,57. Always round to 2 decimal places if they don't say. But normally in the instructions they say, like the front page of your exam paper, they'll say round to 2 decimal places. So alpha is 26.57. This one here. How can we figure out what theta is using other other geometry. So this angle here will be 90 degrees because it's the origin, it's where the two axes cross, so it has to be 90. And if you look at it from, like, maybe if you have to tilt your head a little bit, you'll see that theta is actually the exterior angle of this triangle EOB. So there's the exterior angle of EOB, and that is theta. And what do we know about the exterior angle? It is equal to the sum of the opposite interior angles. So theta is going to be 26.57 plus 90 degrees. And that is 116.57 degrees. Okay, how's that, everybody? You're very quiet, so let's hear if there's any questions or concerns about that. Just give me a thumbs up if you're happy so far. Excellent. Okay, now for your next thumbs up, I want you to give me thumbs up if you think you would have been able to have managed on your own up to this point. In the exam, got these questions, give me a thumbs up if you think you would have been able to answer these questions. On your own. Great, Karabu. Anyone else? Michaela, good? Okay, so for those of you who are struggling with analytical geometry, you have to go and study your midpoint, know how to calculate the midpoint, know how to calculate the gradient, know how to calculate straight line. Okay, Asibi says I would have ended in that 26.57. Other than that, all is good. Okay, now you know, Asibi, this is how they often ask it. They take the angle of inclination and then work it into like another shape or a little triangle, either using the interior angle or the exterior angle. They like to ask a more complex question using angle of inclination. So up to this point, those are the things. I hope you're writing them down so that you know that this you have to know. Okay. Now we have to prove that AB is perpendicular to BC. And I'm going to give you a minute to think about it, and then I'm going to start calling on people to tell me what they think. How are we going to do that? Prove that AB is perpendicular to BC. Okay, have a minute and be ready. Be ready for when I come calling and asking how to do this. Right, who is going to kick us off? Michaela. Let's hear from Michaela. How do you think we will prove that AB is perpendicular to BC? Michaela, you can just unmute yourself. Even if you're just not sure, just tell us what you're thinking. Where do you think you'll start? What do we know about perpendicular lines? Anything. Tell us anything. Michaela, I hope you can hear me. Anyone else? What about Jaden? What do you think? Where are we going to start?
Ma'am, we can work out B because we know the x-coordinate of B is 0. So we could just put that into our formula and then we'll get that B's y is 1. And then we could just work out the formula of BC and the gradient is going to be -2. And then you times that with the gradient of AB, which is half, you'll get -1. Thus, AB is perpendicular to BC.
Wonderful, Jaden. That is really great. Thank you. Yes. So just remember, these questions always flow into each other. So we just found 2 questions ago, we found the equation of AB. It was over here. Y is a half x plus 1. And B is the y-intercept of that line. So B's coordinates have to be 0 and 1. And like Jaden said, when the lines are perpendicular, the gradients, so the gradient of AB multiplied by the gradient of BC must give me -1 for the lines to be perpendicular. Now, the gradient of AB, we worked out a long time ago already. We figured it out also in question 3.1.3, and that was a half. The gradient of BC, we need to calculate. And we use the gradient formula to do that. So we can go 1 minus -3 over 0 minus 2. So that gives me 4 over -2. That gives me -2. And then you see that indeed a half times -2 is equal to -1. Therefore, AB is perpendicular to BC. Okay, slightly more complex question, but also pretty standard. They love to ask about perpendicular lines. Okay, thank you very much, Jaden. So let's carry on. The center of, okay. Yeah, so points E, B, and C lie on the circumference of a circle. So basically what you now have to imagine is that there's this circle going through points E, B, and C. Now, don't forget, we worked out, I'm going to draw a dotted line here, we worked out what the midpoint of EC was way back in question 3.1.1. We worked out that this midpoint here, M, is 0 and -3/2. So now we have to do the center of the circle. So if the circle is going through, and by the way, we've just calculated that these 2 lines are perpendicular, which means that this point M has to be the center of the circle. Why? Because point B, if it's on the circumference of the circle and makes a 90-degree angle, think back to your circle geometry, angles in a semicircle, it means that EC is going to be your diameter and M is then your midpoint of your circle, or the center of your circle. Okay, so even though this is a bit, I've labeled this as routine, but it does require a little bit of thinking. It's only 1 mark. But yeah, you would need to have remembered that you calculated that midpoint. And now you see why, because it's actually coming in here to calculate the center of the circle. Okay, so the equation of the circle in the form x minus a plus y minus b squared is equal to r squared. Okay, so this is not too bad because we've got lots of points to sub in. So we're going to first start off by subbing in the center of the circle. So it's x minus a, so it's x minus 0, in fact. You don't even have to write that. But then it's y, and it's minus 3 over 2, so that will make it plus 3 over 2 squared. And that is equal to r squared. So that's just starting with subbing in the center of the circle, the M point. So that gives me x squared plus y plus 3 over 2 squared is equal to r squared. Okay, so do yourself a favor and don't multiply that whole thing out because it's completely unnecessary for this question. Now we can sub any of the other. We're looking for r squared, right? We're looking for what the radius is. So we can sub in any of the other points that's on the circumference of the circle to find what r squared is. I'm going to take an easy one, point E. And I'm going to make x negative 2 squared. Why do I say it's easy? Because there's a 0 involved, which makes less work. And now you can use your calculator. So that's 4 plus, that's 25 over 4 is equal to r squared. So remember what I said about the previous question as well. End off, you've done all this beautiful work. Now end off with answering the actual question. And that is x squared plus y plus 3 over 2 squared is equal to 25 over 4. Okay, so we've obviously taken longer to do this, but that should have taken you about 18 minutes to do if you were in the exam. Okay, so how are we doing so far? Can I also see some emojis? How do we feel about this question? Now that we've done it all the way to the end, it is, yeah, I think maybe I'll change my mind about this one here. Maybe that borders on the complex side. But even if you couldn't have found the center of the circle, even if your center of the circle is right, carry on. You can still do 3.3.2, even if you got your center wrong and you gave a different coordinate, and, you know, whatever your center was, if it's not 0, negative 3 over 2, you can still carry on and answer 3.3.2 because you just have to sub in some points to find what r squared is. That's it. So that's why 3.3.2 is actually not, it's a routine question. It's definitely not on the complex side. Okay. How do we feel about this? Benedict says thumbs up. Karabo says thumbs up. Asipe also giving a thumbs up. Good stuff. Where's everyone else? Daneo, how are you doing this evening? Jaden's also good. Okay. Rechamuditswe, how are you? Are you managing? Give us a thumbs up. Give us a thumbs down if you're not, eh? It is all good. Timothy. Thank you. Alrighty. Okay. Good stuff. Next one. This is question 4 from that same exam paper. Again, I want you to go through the same process, read through it, circle the questions that you think are easy, label the ones that you think are not so easy, and then plan how you would go about answering the questions. Atinkosi, hi, I didn't even, it's the first time I see that you're here, sorry.
I'm sorry, ma'am. I literally got the class late.
That's no problem. Good to see you. Okay, so take a few minutes to read through, label what you think is easy, routine stuff, what you are going to do first, and then look at the ones, label the ones that you think are not so easy. And I also just want to say, just because something is 7 marks doesn't mean that it's going to be hard, okay? Don't be intimidated. You really need nerves of steel for a maths exam. Okay, when you've done that planning and that thinking, just put a thumbs up so I can see people are done and if we're ready to begin. Okay, let's start. Okay, so we've got in the diagram, the circle is centered at M2 and 1. Okay, so already you know that that's going to be the coordinates of the center of your circle, and it's going to go into your equation. Radius km is produced to L, which just means it's been extended, a point outside such that KML is parallel to the y-axis. LTP is tangent. Okay, so here when you see tangent, start thinking about your circle geometry, because your circle geometry comes into your analytical geometry with circles as well. So if it's tangent, already you should maybe see that the tangent and the radius are perpendicular because of the tan-rad theorem. So you can fill that in for yourself. And what else? S is the midpoint of PK. Right. So they've kindly shown for us that PS is equal to SK. Right. So let's begin. And I would say that this first question, given that the radius of the circle is 5 units, show that B is 4. That is a routine question, I would say. The reason I say that is because you have the center of the circle. So that's x minus 2 squared plus y minus 1 squared is equal to 5 squared, the radius squared. Now it's just going to be a matter of subbing in the x coordinate so that you can find what the y coordinate is, because t lies on the circle. So x is minus 2 and y is b, and that is 5 squared. So this is going to go to 16 because minus 2 is minus 4, and we're squaring it, that's 16. This is a bracket that you have to FOIL out, and 5 squared is 25. Okay, in my next step, I'm going to take the 16 over to the other side, and at the same time, I'm going to go 25 minus 16 is 9. And b squared is minus 2b plus 1. Okay, so you've got a trinomial that you have to factorize. So then b is equal to 4 or b is equal to negative 2. Now, which one is it going to be? Is it going to be negative 2 or 4? I would say it's definitely going to be 4 because it's on the positive y. Negative 2 and 4. Okay, so you have to know for your exam how to work with the equation of the circle in all the ways. So finding the radius, finding a point given the radius, where does the center go, all of that stuff you must know. Okay. Just checking my work here because I feel I might have made a mistake, but I don't think so. Okay, now what are the coordinates of K? What are the coordinates of K? And that's 2 marks. The coordinates of K. This is something about analytical geometry that I personally find very irritating because it's got all these small questions. It's like 2 marks. That's actually so simple, but when you look at it the first time, you're like, don't know. Okay, who can give us the coordinates of K? Who wants to try? The coordinates of K. Come guys, who can help us? Who's got the coordinates of K? X is 2, that's right, thank you. X is 2, and then Y? I'll give you a hint for Y. We know what the radius is, right? The radius is 5. Come, someone give me Y. The Y coordinate, I agree. The X coordinate is 2. What is the Y coordinate? We know the radius is 5, and we know that the Y coordinate at M is 1. Coco. -4, yay! Okay, there's 2 and -4. Excellent. Okay. What is the equation of the tangent LTP in the form y equals mx plus c? Now, where is LTP? Okay, LTP. This is also routine. The reason I say that is because you have to know how to find the equation of a tangent. It is like a non-negotiable. Got to know it. Y equals mx plus c. Okay, where are we going to start? Tell me, someone. Claire, what do you think? Where are we going to start? Come, guys, we've got 15 minutes to finish this question. Let's give, okay, we have to find the equation y equals mx plus c. Benedict, let's help Claire. You can answer, Benedict.
You find the equation of the radius, and when you get the equation of the radius, you can get the equation of the tangent, because both the gradients must be -1. And then once you have gradient of the tangent, then you find the equation.
Good, great. Okay, so we're not going to find the equation of the radius, but we are going to find the gradient of the radius, because the radius and the tangent are perpendicular. So everyone who wasn't sure how to do this question, this is how, make some notes, write some notes for yourself. This is how we do it, okay? We find, first of all, the gradient of the tangent. Okay, I want everyone to do that. The gradient of the radius, sorry. I want everyone to do that now. Calculate the radius, the gradient of the radius. So in other words, the gradient of MT. And when you've got it, please put it in the chat. Okay, I'm going to agree with Jaden that it's -3/4. Okay, we've done a few gradient questions now. So all you do is you take the coordinates, put them into the gradient formula, and you should get -3/4. Now, that's the gradient of the radius. What is the gradient of LTP then? If the tangent and the radius are perpendicular. We did perpendicular lines just now in the previous question as well, over here.
4/3.
In the green. Yeah, it's 4/3. Who gave me that? The reciprocal. Good, yeah. We're waking up, Matrix, late on a Wednesday night. That's 4/3, okay? So 4/3x plus c. Now, how are we going to find c? Also, think back what we did over here. We found gradient, and then we subbed in a point. We're going to do the exact same thing here. We found the gradient, it's 4/3. We're going to sub in a point. So do that now. You can sub in. There's only one point to sub in, and that's -2 and 4. So when someone's got that, please put it in the chat so that we can write it down. Sub -2 and 4. And then just give me the answer when someone's worked it out, please. (20/3). Okay, it seems like we all agree that y is equal to 4/3x plus 20/3. Okay, now we have to work out the area of LPK. Okay, so this is a problem-solving question. It is 7 marks. We haven't had a problem-solving question in a while now, so this is definitely it. Okay, so we have to work out the area of LPK. Okay, have a look. Think about what you might do. Where you would start, what your plan is. Okay, let's try. I hope we have enough time to finish it. Remember, if you get to this question in the exam, it's 7 marks. There's 7 minutes, and if you've worked on it for 7 minutes, and maybe you haven't finished it, or you haven't, you know, you're getting stuck, or you don't know what to do, and you're trying things, but it's not working. 7 minutes, you have to be strict with yourself and move on, okay? Because further down in the exam, this is only question 4. So further down the exam, there are a lot more marks that you can get. And you don't want to stress yourself out so badly that you can't think for the rest of the paper because you're now stuck on question 4.2.3. So be disciplined with yourself. Look at your watch. 7 minutes, it's done, it's time to move on, okay? Now, if you look at triangle LPK, you will see that it's not straightforward because it's not a right angle triangle. So we can't go half base times perpendicular height because we don't have half the base. We don't have the perpendicular height. It's not a 90-degree triangle. Okay, so we would either need to get this thing, maybe that line as the perpendicular height, or we can go for the exterior height of the triangle, which is here. Okay, so that is LPK. Now bear in mind they've just asked us to calculate the coordinates of K a few questions back. So we've got the coordinates of K. So to do our half base times height for this question, we would basically need to know what the length of LK is, this distance, what that distance is, and then somehow figure out a way to work out. I'm going to call this here, let's call it something that we haven't used yet, an N. Let's call that N. Okay, so first of all, we somehow need to find the coordinates of L. And have a look, what have we figured out so far that can help us with the coordinates of L? What have we worked on so far? Okay, so that's the one thing. Why do we need that? So that we can calculate the distance of LK. Then we need the coordinates of N and the coordinates of P to calculate that distance, Pn. Okay. How can we, let's start with L. How can we find the coordinates of L? Does anyone know? Does anyone want to try? Remember this line, Ln is parallel to the y-axis. So we again, all along here, at point N and at point L, the x-coordinate is still the same, it's still 2. And that's 2. Now, if you look at our previous question, they asked us what is the equation of line LTP, and we got it over here. So to find the coordinates of L, we can use that equation because y is 4/3 and x is 2 plus 20/3. And that gives me my y. Okay, are you with me, Matrix? Please speak up if you need me to explain again. Okay, so that is 28/3. Okay, 28/3. Now, how will we find the coordinates at N? That will be our next one. Actually, before we go to N, let's do P. Now, if you look at P, you see that S is the midpoint of PK. So we can calculate the coordinates of P by using the midpoint formula, because the midpoint is -4/3 and -6. So 2 plus the x-coordinate at P divided by 2 must be -4.5. And for the y coordinate, same story. -4 plus the y over 2 must give me -6. So now we're just going to solve these two equations. 2 plus x is going to give me -9, and then x is -11. And then same here, we multiply by the 2, so -4 plus y equals -12, and then y is 8. -8. Okay, so that gives me the coordinates at P. It's -11 and -8. So because I've made this line PN perpendicular, it means that P and N will in fact have the same y coordinate. So this will also be -8. Okay, and now we're just going to do half base times height, because we can just use the vertical and the horizontal distances. We don't even have to use distance formula. Running out of colors here. I've got too many colors. So this distance, LK, is 28. -4 to 28 over 3. That distance, let's add that together. That is 40 over 3. And then this height, PN, that distance from -11 to 2 is 13. So that's going to be area is half the base is 40 over 3. And PN is 13. And then we get our answer. Okay, 260 over 3 units squared. Okay, I know that was a lot. That was quite a lot of thinking. But it's actually not too bad if you just get going on it. Right. Okay, we have gone 2 minutes over time. Sorry about that, but we just needed to finish that question. Thank you so much, Matrix. It was good seeing you all here again tonight. Thanks for your perseverance. And Monday night, we'll be back again with Q&A. Please send some questions. I haven't had any questions this week, so please send some questions for us to do. Okay, bye. Over to Coco.
Well, I was going to say bye too, because we really don't have anything for you guys other than, Marlies, do you mind if I put your email in the chat just so they can remember where to send it?
Sure, yeah.
Sure, I'm just going to do that quickly.
Can I ask something, please?
Yes, please do.
Where you got when you're calculating the coordinates of P by you times the 4 1/2 times 2, right?
Yeah. So -4.5 times 2 is -9.
Is
And then I
-4.
took the 2 over to the other side.
Isn't it
And then
-4? Because I get -4 instead of -9.
So it's -4.5 times by 2.
Yes.
Yeah, I think just check it on your calculator. -4.5 times by 2 is -9.
Oh, okay.
I think it might be easier if you turn that -4.5 into an improper fraction, then you'll see how it becomes 9.
Sorry. Okay.
Yeah, or if you go -4.5.
Times 2.
Coco, I'm actually Marilise at watobe.com.
Oh, not .za. Oh, okay.
Yeah.
I'm sorry.
It's okay.
Yeah.
Right. Thanks so much, guys. Have a good weekend.
Okay, everybody can just
so-
take down the email before you have to go.
Yeah.
And yeah.
Please send us questions.
Sorry, ma'am. Can I ask a question quickly?
Yes, please do.
How did you get the 40/3?
40/3. Oh, the 40/3. Oh, so if you look here at the, let me just get my pen. So the y coordinate at L is 28/3. And this y coordinate is -4. So you add those distances together. So up to here is 28/3 plus another 4 is going to give you 40/3. So you add the 28/3 plus 4.
Okay. I see now.
I hope I did it right.
I see now.
Plus
Thank
4.
you.
Yes, that's 40/3. Okay,
We're
you're
most
welcome.
definitely out of time. We do have to go, unfortunately.
Okay. Bye.
Thank you, guys.
Thank you.
Thank you, guys. Bye-bye.
Bye-bye. Bye, Zulihle.